Greetings, pre-calculus students, to another lesson in our unit on radians and trig. So we just finished off a few days of just reviewing our trig, being able to use it to solve the missing sides of missing sides of a triangle, missing angles of a triangle, just setting up the ratios. So we finished those few days of review. Now we're going to continue our discussion of triangles. We're not doing our triangles just yet because in order for us to make our next big step in this unit, we need to make sure we understand the nature of a couple of special right triangles. So we're going to be looking at a couple of special right triangles in today's lesson. So the reason why these right triangles are special is the fact that the missing sides of these right triangles, and even the missing angles, though typically we focus on the missing sides when we talk about these types of right triangles, can be calculated without using trig. Okay? So the missing sides of these right triangles can be calculated without using trig. So we're going to talk about two special right triangles today, the 45-45-90 right triangle and the 30-60-90 right triangle. Now, for some of you, this might be a review. Some of you might have covered this back in geometry, so just this will just be a reminder for you. For others, this might be completely new. So let's get to it. So the first one, the 45-45-90 triangle. So let's talk about the nature of the 45-45-90 triangle. Okay? So let's say that the side of this right triangle, let's just label it as x. We can label it whatever we want, but let's just label it using the variable x. So we're labeling the non-hypotenuse side of this right triangle. We know this is the hypotenuse, so we're labeling the non-hypotenuse side of this right triangle x. And actually, it doesn't matter which side, as long as we don't do the hypotenuse, it actually doesn't matter which side we label, because for those that might have remembered, whenever you have a triangle with two equal sides, two equal angles, that means it is an isosceles triangle. Now, the name of it is not important, but it is important to remember that in an isosceles triangle, so when you have two angles that are equal to each other, that are congruent, that means two sides of the right triangle are also congruent. Okay, so that's important to remember as we go through this proof of this right triangle. So we're trying to establish a relationship between these two sides and the hypotenuse. Well, in the past, whenever we've known two sides of a right triangle, the way we found the third side is we've used the Pythagorean theorem. So let's do that. Let's use the Pythagorean theorem to try to see what this hypotenuse is equal to. Okay, so Pythagorean theorem. So we have x squared plus x squared is equal, we'll just call the hypotenuse h. So h squared. Okay, so a squared plus b squared is equal to c squared. In this case, x squared plus x squared is equal to h squared. So we have x squared plus x squared. Okay, so that gives us 2x squared. Gives us h squared. So remember, we are trying to solve for h squared. Okay, we are trying to solve for h squared. So at this point, in order to solve for it, we need to take the square root of both sides. So by doing so, the squared cancels out, and we are left with, why did I use red? We are left with h on the right side. And on the left side, well, we know that the square root of x squared is just going to be x. Right? So the square root cancels out the x squared. Now we're left with square root of 2. Okay, now we're left with square root of 2. Well, the square root of 2 is just the square root of 2. There isn't really any special thing to it. So there we go. We have just discovered that the hypotenuse of this triangle is equal to x times square root of 2. X times square root of 2. And that relationship is going to hold for any 45, 45, 90 triangle. Okay, so the two legs, the two non-hypotenuse sides of the triangle will be congruent to each other, will be x, and then the hypotenuse will be x times radical 2, or x times square root of 2. Okay, so it's really important to try to remember this relationship right here. Okay, and then you'll see once we actually go to a problem how this relationship actually helps us in solving for sides. Okay, so now let's look at the second one. The 30, 60, 90 triangle. Well, the triangle in front of you, you might be wondering, that does not look like a 30, 60, 90 triangle. It isn't. The triangle in front of us right now in this slide is not a 30, 60, 90 triangle. This is, for those who remember in geometry, an equilateral triangle. Okay, an equilateral triangle. And it is called an equilateral triangle because all three sides are the same measure. All three sides are the same measure. So x, x, x. Okay, x, x, x. Now, for those that remember, since the angles of a triangle have to add up to 180, since the three sides have the same measure, the three angles will have the same measure. Okay? Now, we're going to do something here to create a 30, 60, 90 triangle. We're going to do something here to create a 30, 60, 90 triangle. And what are we going to do? We are going to split that side. We're going to draw a vertical line from one of the vertices, so one of the vertices of this triangle, straight down. Okay, straight down. Creating a right angle there and also bisecting this angle. So this angle here now, this smaller angle is now 30 degrees because half of 60 degrees is 30 degrees. And actually, for the purposes of this proof, I'm going to change something up here. It'll make sense a little bit later. So I'm not going to call these sides x. I'm going to call these sides 2x. And it doesn't really matter what we call them. But you'll see the relationship that I want to establish with the 30, 60, 90 triangle. It's a little bit easier if we treat it as 2x as opposed to x. You'll see once we get there. Okay, so not only does this vertical line that I just drew, bisect that angle into two equal halves, it also bisects this bottom side as well. So since it cuts 2x in half, that means that bottom side is just x. Okay, so that bottom side is just x. So we're just going to be focusing on, just to highlight it, we're just going to be focusing on this right triangle. So hopefully now you can see a 30, 60, 90 right triangle. Okay, by cutting a equilateral triangle in half, we just created two actual 30, 60, 90 right triangles. All right. So now we're going to do the same thing that we did before. Okay, we're going to do the same thing that we did before where since we know two of the sides of this right triangle, we're going to find the third side, okay, which in this case doesn't really matter. We'll just call it y. We'll just call that third side y. Okay, we're going to find the third side by using the Pythagorean theorem. Okay, we're going to find the third side by using the Pythagorean theorem, which remember, you can always do that whenever you have two sides. If you know two sides of a right triangle, you can always use the Pythagorean theorem. So let's set it up just like we did before. So Pythagorean theorem. Okay, so in this case, we have x squared plus y squared is equal to the quantity 2x squared, because don't forget, the longest side is the hypotenuse, so that is why the 2x is on that side of the equation. So x squared plus y squared is equal to the quantity 2x squared. So remember, we're trying to solve for y. Okay, we're trying to get y by itself. So let's see what we can do here. So this is just x squared plus y squared. The quantity 2x squared is 4x squared because we're literally just doing 2x times 2x, so that gives us 4x squared. And once again, we're trying to solve for y squared. So let's try to slowly but surely get it by itself on one side. So that cancels out. We're left with y squared. So 4x squared minus x squared is 3x squared because it's just 4 minus 1, like terms. And just like the previous problem, we want to cancel out the squared part of our equation now. So let us square root both sides. So the squared disappears. Remember, the square root of x squared is just x. Right? The square root of x squared is just x. And now the square root of 3 is just the square root of 3. There's nothing special there. So that means this y side is equal to x times radical 3, or x radical 3. Okay? So just to recap on this slide, so if you have a 30, 60, 90 triangle, you want to label the hypotenuse. You want to label the hypotenuse 2x, because if you notice, that's how we did it in this proof. We labeled the hypotenuse 2x. You want to label the side next to the 60 degrees. Okay, so the side on the bottom here, so the side adjacent to 60 degrees, you want to label that x. Okay, so the side adjacent to 60 degrees, you want to label that x. And then you want to label the side adjacent to 30 degrees x times radical 3, or x radical 3. So that's the relationship. So this relationship holds for any 30, 60, 90 triangle. Okay, this relationship holds for any 30, 60, 90 triangle. Okay, so now let's use these relationships to solve for some missing sides. So let's look at our first problem. So example 1. So find the missing side of each triangle. So here we have a 45, 45, 90 triangle. How do we know it's 45? Because this angle has to be 45, because once again, the angles have to add up to 180. So 90, 45, the third angle has to be 45. Okay, so let's see what we got here. So we know this is the hypotenuse. Okay, so just a reminder, when you have a 45, 45, 90 triangle, the hypotenuse we label as x times square root of 2, and then the other two legs of the triangle we just label as x. Okay, so let's do that. So the hypotenuse we're going to label as x times radical 2, and then these other two legs we're just going to label as x. Okay, so let's see. So we know x is equal to 2 square root of 2, right, because we just labeled it that way. We know b is equal to x, which means b is also equal to 2 square root of 2. And we know a is equal to x times square root of 2. So we just do simple substitution. Right, I just replaced the x with a 2 square root of 2, because that's what it's equal to, right? X is equal to 2 square root of 2. So now we just multiply it out. What is 2 square root of 2 times square root of 2? Well, for those who remember the way we multiply square roots, you literally just multiply the numbers inside the square roots, okay? So when you multiply square roots, you just multiply the numbers inside the square root. So that means our final answer is 2 times square root of 4, because 2 times 2 is 4, right? So we can actually simplify this further. Square root of 4 is just 2, so 2 times 2, so our final answer is 4. So there you go. So b is equal to 2 square root of 2, and a is equal to, let me just finish it off there, a is equal to 4. Okay, so similar to when we were working with trig, and I placed a emphasis on being able to label the sides of the triangle so that we knew which side ratio which side ratios we were using. We were setting up the trig equations. The same idea here, okay? You want to be able to label them appropriately using the special relationships that the special right triangles have with their sides. So now let's look at another one with the 45, 45, 90. Let's look at one more. So this one's a little bit different. This time, once again, just to redraw it here, 45, 45, 90. So we know this. We know the hypotenuse is x times radical 2, and then the other two legs are x and x. So let's label it the same way. So this is the hypotenuse. 4 is the hypotenuse. So x radical 2, and then that's just x already, and then that's just x. All right. So this one's a little bit different. So let's write it out now. Let's see what we get. So we have 4 is equal to x times radical 2. Well, how do we solve for x? We solve for x by dividing both sides by square root of 2. So let's do that. Let's divide both sides by square root of 2. So square root of 2, square root of 2. That cancels out, and we're left with 4 over the square root of 2 is equal to x. So 4 over the square root of 2 is equal to x. Now, you could leave your answer that way. Leave your answer that way. But typically, we do not leave square roots in the bottom of our expressions. We do not leave square roots in the bottom of our expression. So for those that remember, the way you get rid of a square root is you multiply it by itself. So we're going to multiply this fraction by the square root of 2. But remember, whatever you multiply the bottom by, you have to multiply the top by. So we're going to multiply both the top and bottom of this fraction by the square root of 2. So this gives us 4 square root of 2, because those two, so the 4 and the 2 don't multiply in this case because 4 doesn't have a square root and the 2 does. And then the square root of 2 times the square root of 2, just like we saw in the previous problem, is the square root of 4. Finally, the square root of 4 is 2. Okay? And then if you really wanted, so we got rid of the square root in the denominator. If you really wanted, you could simplify this further. Since you have 4 in the numerator and 2 in the denominator, we could simplify this to 2 square root of 2, because the 4 reduces to 2 and the 2 reduces to 1. 4 divided by 2 is 2. Either of these answers are perfectly fine. You don't have to write it in lowest terms. So that is what x is equal to. That is what x is equal to. And we also said that y is equal to x. Well, we just said x is equal to 2 square root of 2. So we're done there as well. And there you go. There are your two sides. So that's the 45, 45, 90 triangle. Now let's do the 30, 60, 90 one. And then you'll get a chance to try it a couple problems on your own as well. So 30, 60, 90 triangle. So we know this is a 30, 60, 90 because that's 90, that's 30 degrees. So this is 90, that's 30 degrees, so this has to be 60 degrees. So recap, if I were to redraw that right triangle that we had in the proof earlier. So that's 60, that's 30. So once again, remember, the side adjacent to 60 degrees, actually let's do the hypotenuse first because that's easy. The hypotenuse we label as 2x. The hypotenuse we label as 2x. The side adjacent to 60 degrees we label as x. Okay, so the side adjacent to 60 degrees we label as x. And then the side adjacent to 30 degrees we label as x radical 3. So let's do that for this one. So let's see. This is 2x. This is x radical 3. Give me a second here. Okay. And now we're just going to solve it. Oh, I'm sorry. I missed one. And then this is x. Sorry about that. And that's x. Okay. So let's see. We know that x is equal to 2, because we just said x was equal to 2. And we know that u is equal to 2x. Well, if x is equal to 2, that means u is equal to 4, right? 2 times 2. And we know b is equal to x radical 3. which means v is equal to 2 times radical 3, because once again, x is radical 3. And then that's it, we're done. This one was a little bit more simpler. We didn't really have to simplify anything. So u is equal to 4, and v is equal to 2 radical 3. So let's do one that's a little bit more trickier. Okay, let's do this one. So another 30, 60, 90 triangle. Okay, so once again, we have our 30, 60, 90 triangle. So 60 degrees, 30 degrees. The hypotenuse we always label as x, or I'm sorry, 2x. Whoa. The side adjacent to 60 degrees is x, and then the side adjacent to 30 degrees is x radical 3. Okay. So let's see. So the hypotenuse we said is, so this problem already has an x in it. So this might confuse some people. So in this case, what I do, so since this problem already has x, we should probably change the variable that we're going to use. So instead of calling it 2x, let's call it like 2b. Okay, let's call it 2b. So that means y is equal to b. The side adjacent to 60 degrees is equal to b. And then the side adjacent to 30 degrees is equal to b times square root of 3. Okay? So now let's write out what we have. So let's see, we know that b times square root of 3 is equal to 5 square root of 3. So let's see, how do we get b by itself? Divide both sides by square root of 3. So divide both sides by square root of 3. That cancels out, and on the right side it also cancels out. So that means b is equal to 5. B is just equal to 5. And we said that y is equal to b, and we just said b is equal to 5, so it means y is equal to 5. Additionally, we said x is equal to 2b, and since b is equal to 5, that means x is equal to 10. 2 times 5 is equal to 10. So x is equal to 10, and y is equal to 5. So it's all about, once again, it's all about labeling your triangle and then doing some simple, well, hopefully simple, equation solving to figure out what the other variable letters must be equal to. So once again, you'll see in this problem, I did not call this side 2x, only because since the problem already used x as a variable, it can get confusing if you use x again to represent a different thing. So that's why for this problem, I just changed it. Instead of 2x, I made it 2b. You could have chosen any other letter you wanted to. Okay, so the next two problems, okay, are going to be on your own, okay? So this one is a 45, 45, 90 triangle. So just like if you want to go back to example 1, look at those two examples, you'll see me labeling the triangle and then just figuring out what the other two sides are. And then the second problem I want you to try on your own is this one, a 30, 60, 90 one. So once again, just like example 2, you want to label it appropriately for a 30, 60, 90 triangle and then solve for whatever's missing. Okay? As usual, let me know if any questions do pop up. Leave me a comment in the classroom. I hope this lesson went smoothly. And as usual, I do want you to make sure to turn in addition to your notes, the work for these two problems. Just make sure you do that. Otherwise, I hope you all enjoy the rest of your days. Stay safe, and I will see you later.